Hey guys, we are recording this session. So you should see a red dot that shows that it is recording. Well, if you don't see that, we have a problem to fix. But I'm assuming that you see it. With that said, let us project my screen. And the screen should be visible to you. And I am showing currently a browser showing Amazon's console. In there, we will focus today on the idea of a virtual private cloud. That's the core concept we'll discuss. But instead of going to the website and just messing around with the actual exercise, what I'm going to do is just describe to you what that concept is. So here is this massive public cloud, and this one we are talking about Amazon Web Services. They also provide a VPC solution. There is another company called Google Cloud. They also provide a VPC solution, and they call it VPC as well. So the same name used in case of Azure Cloud. They don't call it VPC. They call it virtual network. But it's the same thing. It is VPC basically. Just different name, but who cares? At least I don't. I don't think you do either. It's just a name. But what is a VPC? So if you think about, just imagine I'm going to create a Venn diagram of sorts. This is the world, like public at large. In there, we have, say, this Amazon cloud, for example. And somewhere in here is your company, your corporation company. And you are typically here. Sometimes you are in your home here. And so in that scenario, you want to be able to connect to your subsection. It's a portion of the Amazon's public cloud, and you will call this your VPC. And when you are home, or when you're at the company location, you should be able to connect to the VPC. And also, people at large, people outside, like public, they should be able to connect to only certain portions that you want them to be able to see. Whatever you expose, that portion should be visible to public. And certain other portion, like here, the secret stuff, you keep these secret things. Those things should be visible only to you, to your company employees, not to the public. So that's the kind of demarcation of resource access that we need to be able to put together. And we will do that by using rules around security. So they are called security groups by Amazon Web Services. Google calls it firewall rules. And so various companies use these things in different names. But essentially, these are rules to allow access. So there is a source, there is a destination, there is a protocol, there is a port number, and there is a method of access, whether it is TCP or UDP. And then you define, basically it's a table that says, from here, you want SSH protocol port number 22 on TCP connection, allow for this destination, whether you allow or not allow. So you allow or not allow. You can basically create those set of rules. It's basically a table. This table collectively is generally called security group or firewall. That's what you will see in most cloud examples. Now, why are we talking about this thing? Because we want to understand how do you configure that VPC. Now, if you go and ask Amazon, hey, Amazon, give me a VPC, click. And so you go to the VPC section, and there you will find that you have to first thing first, remember, choose the region you want to play with. If you're not in the right region, you will get confused. So remember, you can choose whatever you like. Like I just switched over to the Oregon region, or maybe I switch over to Virginia region. But effectively what I'm doing is being fully aware that I am in Virginia. And that is important. If you forget that, you will get lost a little bit. Another thing to remember is that you have to have a key pair provided to that region. This Virginia region needs to know that you have a pair is provided in the EC2 section, not here. So you have to go to the EC2 section, and in there in EC2 in the compute section right there, you have to make sure that your key pair is there. So this key pair, you need to have your IDRSA key pair available in that location. What does that translate to? It basically means, I have this virtual machine, you have the public private key pair, you start the VM and give your public key to that region in that cloud. And Amazon is kind of designed in a bad way that you have to give that key pair every region one by one. The keys do not propagate by itself, which is silly. But that's what we got. So just deal with it. Having said, I have made sure that my key pair is here, and I will probably double check, because this is one mistake if you do and you don't have the correct key pair with you and the private key corresponding to you in your command and control, you will fail to connect. So there is no point in wasting time further before. So it's a good idea to check the region you want to play with and the key pair you want to use. So I will double check this one more time. So I'll go to my machine like here, and in that machine, I am going to cross check. Basically open the terminal and say here, what is my cat id underscore rsa dot pub. My public key should be given to the Amazon cloud in Virginia region. So I'll copy this key like that, double check, make sure that it is there indeed. So import and say id underscore rsa and paste. And this is a duplicate name. So maybe it's easier to just delete that key pair, right? Like that. So goes. And then I import and id underscore rsa and paste, and then say import. So my key pair is absolutely there, and I know for sure this is the key pair I have in my computer. I have the private key corresponding to it, and I just gave the public key to these guys. Having done that, let us now go back to the VPC section. In here, you have a wizard. You can just click the wizard and get a VPC. It takes like 2 seconds. But that's not what we want to do. And I'll tell you why. But they have given us 4 choices. There is this single VPC, single VPC with a single public subnet. There's another choice. So we'll discuss these choices first. But we will not exercise these choices at all, because they are for people who don't know what they're doing. Like, they're simple choices, click a button, get something, move on. But that's not how big companies operate. So first one, VPC with a single public subnet. What does that do? Let's go understand the picture here. If you look at the picture and compare with my hand-drawn picture, which I will now draw, what they're doing is essentially in your virtual private cloud that you will create, or rather the wizard will create, they will give you a subnet. And then this subnet is basically connected to a gateway, and you will create a machine, another machine, another machine, and each of these will get a public IP, and that's the VPC. Now, this is not a sophisticated, secure design, by the way, by any stretch of imagination. Now, let us compare with this, what we have here. It is worse than what you have in your home network. Your home is better than this design. I'll tell you how and why. Your home network is slightly better in that you have a gateway, which is basically a modem. And the modem gives you a place to hook up your router. So this is your router. The router then gives you private IPs. And this provides you a private subnet, basically a subnet of place where you can connect more machines. And router itself is on the public subnet. So in your home, you already have this private public separation, but this first design doesn't even bother to give you that. In your private subnet in your home, you typically have seen that you will have a router here that will generate an IP address internally, something like 192.168.0.32 or some sorts of something like that. You must have seen these kind of addresses. These addresses are private. They are not routable from the world outside. This guy on the internet, public guy, this person cannot traverse through your router and get to this location. It is not routable. What does that mean? It basically means there are certain ranges of internet addresses that are defined as 192.168 dot whatever number you want to put here, dot whatever number you want to put here. This range can be in between 0 through 255 and 0 through 255. That range of addresses is called out as RFC 1918 by the IETF as one of the private non-routable addresses. If you look at RFC 1918, you will find this location, which is what this thing is. It's basically this RFC. You can read more about the RFC itself. And this is the request for comments 1918 by the IETF. But this is kind of convoluted reading. I would rather simplify the whole thing for you and give you a pointer to this Wikipedia page, which calls out those ranges of addresses. So here, IP address range, 192.168.0.0 all the way through 192.168.255.255. That range, there are 64K, as in 65536 addresses available in that range of addresses. That is a 16-bit block. And you can have 64,000 machines, 64K, I should say. K as in multiply by 1024. That makes it 65536 addresses in that range. The shorthand notation for this entire range, there is a shorthand to write this range of addresses. That shorthand happens to be written like this: 192.168.00/16. This 16 is an indication of the fact that these last two places are a variable for the range that you're describing. So this is how people typically write a range of addresses. It is also known as CIDR, or classless internet domain routing. Classless interdomain routing is a way of writing a range of addresses. Similar to this one, which is very commonly used in home routers, there is another block, another address range, which is this 20-bit block, which is slightly bigger. It gives you about 1 million addresses. The range is 172.16.00 all the way through 172.31.255.255. That gives you roughly about 1 million addresses, and that is represented with a CIDR block of 172.16.00/12. As you will notice, this /12 number becomes smaller, and this number becomes bigger. If you look at this range, it is an even smaller number, /8. So the resulting number of addresses available becomes even larger, about 16 million addresses. In this range, a 24-bit block address, 10.0.0.0 all the way through 10.255.255.255. That is a big range of addresses available on the private address space, called out by the IETF as not routable private addresses. So these addresses, if you have, that machine is not routable from the internet. That is exactly what we would like to have in a virtual private cloud, is to not be able to have people route to our machines internally because it is a private area. The first design we looked at doesn't give you that at all, this design in the Amazon console. It gives you a public subnet. There is no private subnet. And this is, I would say, there is a use case for this, by the way. That use case is simplicity. You just get a machine, get an IP address. This is similar to like DigitalOcean, for example, or Vultr Cloud. Just go there, log in, get a machine, boom, done. So the simplicity of DigitalOcean is kind of impressive. I like it so much so that I actually sometimes use it. So I'm going to log in, paste my token number. Come on, token. And then it'll log me in. It'll let me get a machine as I need. And it gives me just the similar design that you're talking about here. Public subnet, the machine in the subnet, I get access. It gets a public IP, and I'm done. Simplicity in the design is beautiful. Same with Vultr Cloud. And Amazon seems to be a little bit daunting and comprehensive and complex and all that. So what Amazon has done is created a simpler version of Amazon's EC2 behavior. It's called Lightsail or something, some name they have chosen. Let's go find out that thing. So it's very similar to what these guys have. So they have this thing called Lightsail. It's a different product, again, for the competition with DigitalOcean, if you will. But they have simple thing, like, create an instance. So pretty similar to you choose whatever you want, OS. Say I want to get Ubuntu, and then you choose the $5 machine, $10 machine, whatever you like, and click, and you get. So it's a very simple way of accessing the cloud, just like these guys provide, or other clouds provide, simpler. And that is this design implemented, the first wizard choice. that is not really suited for a high-end comprehensive application in the enterprise. So we're not choosing that route either. You can, of course, select and click and be done with it. That's not what we want to do, though. So we'll cancel out. You can play with it on your own. I'm not stopping you from playing with it, but just saying that I will not be using it. The other idea here is the second idea, which is the one we just discussed. It's a common scenario in your home usage, for example, where you have a public segment, subnet, and a private subnet. The public subnet has the NAT device. This NAT is basically a router. Let's go back here on the sheet of paper. We'll talk about that second design. So there is a public subnet, there is a private subnet, there is a router here. The router device that you have in your homes typically has a bunch of different functions. One such function is network address translation. That is the function that we are most interested in our cloud scenario. And so we just call the device a NAT device for that reason, because that's what we are primarily interested in. We are not interested in the other functions that the router typically provides. We are primarily interested in just the NAT function. So we typically use the device or call that device as a NAT device, but it is basically conceptually similar to what a router will do in your home. So you have a modem, which is like a gateway you will get in the cloud context, a modem from Comcast, Quest, those guys. Gateway is what you will get in the VPC scenario. You will connect the gateway directly to a NAT, the modem to a router, same idea. This is your public segment. You get a public IP for your NAT device, for your router. The router is your public facing IP. This is the same IP that you see when you go, what is my IP.com. This IP that you see, which you will see, is this IP, is the address that my router has from the world outside, the public IP address provided to my router from the Comcast company. You can even say that it is thinking that I am in New Jersey for some reason, and I am in the US using Comcast Cable Communications. But I'm not in New Jersey, I'm in Sammamish. Having said, this is the third design. The third design is similar to the second one, except there's one addition here. This is a VPN provided to you. What does that do? It basically is the same design with public and private subnets, but a VPN connection added. What does that do to you? In a clean sheet of paper, you have a public subnet, you have a private subnet, and you have a gateway and a NAT device and a place to create machines here and here and here, more machines. In the private area, keep them protected. The public area, which is where NAT sits, and you have a special gateway connection between the cloud, the virtual private cloud, and your company. This connection is called a VPN connection. That is established for you in the third design, so that you can, in your company, just randomly choose to go visit this machine or that machine. You can traverse because it is routable now that you have a VPN connection, virtual private network connection from your company to your virtual private cloud. That is giving you a special route dedicated to just your company that will let you route your traffic from the corporate data center through a VPN connection onto the cloud. So that is a connection that is established if you choose this option. A fourth choice is it's a different choice. It's like dedicated isolated island. This island that we are creating in the VPC has absolutely no way to connect to the internet. That is a use case. Some companies like to have that. So that's why they have this design where there is a cloud, there are some subnets, and there is no gateway, and there is no way to connect to the internet at all. All you get from your company is a way to connect to the cloud. So you can connect to these machines that you might have on that private subnet, and you can operate whatever you want to do with those machines. They will help you. This is like an extension of your office. They're internal machines just sitting in the cloud, and you play with them, mess with them, do whatever you want, but the machines cannot connect to the cloud by themselves because there is no route. There is no connection at all. Absolutely nothing. So you don't get them. That's the fourth design. You have a subnet. It is in a private cloud, and that's it. It is connected to your company through a VPN channel. And those are the four designs available. We can select any one of them, but we are going to select none of them. Instead, we'll go here and go to the VPC section. double check that we are still in Virginia, and then look at how many VPCs we currently have. And I see that I have only one. What do I have? Let's go see that. I see that I have this thing called ignore. I deliberately named it as ignore because I want to ignore it. It is my default VPC. It is there. And I would strongly recommend you to not delete this default VPC, because if you do delete, one of the future exercises you will struggle with. And then you have to open a support ticket with Amazon. So you don't want to delete this particular VPC. Instead, I suggest ignoring it. Just label it as ignore. So label this as ignore and just ignore it. Now, having ignored this VPC, we have no VPC right now. So what do? We create one. So you click the create button. This is not a wizard, so it does not automatically create things for you. You have to actually provide input to it. And you have to walk through those steps to make sure that you are getting the design you expect to see that you may have in your mind. And since you are creating it from scratch, you get to modify it as you go along. You know exact component that you're putting together, and you can expand. So in a complex setup, there is a question from Travis about VPN implementation. We'll have an example of that coming up. Don't worry. So in this scenario, I'm creating a new VPC. And that VPC, what I am going to do is assign a range of addresses. So the range that I have available here are, what ranges do I have? Maybe all these ranges. So this is the range of addresses that I have available. The largest CIDR block I can get in this range is actually 10.0.0.0/8. That will give me 16 million addresses. But Amazon has a limitation. I think Amazon supports only 10.0.0.0/16. So that's the maximum size that I think is supported by Amazon. I may be wrong about the actual limitation, but this is a suggestion that they have here for us, which is giving us the largest VPC you can get away with, largest CIDR block. It says actually, there is a limitation right there. It says you cannot specify an IPv4 CIDR block larger than /16, meaning any number that is /15 or 14 or 12, or those numbers are going to be larger ranges of addresses, not allowed. /16 is the biggest you can get in one VPC. And I'm going to choose this example as such, 10.0.0.0/16. And I'm going to give this VPC a name. And in there, I will provide my range of addresses that I would like to allocate within that VPC. So this is 10.0.0.0/16 is the range of addresses that I'm taking. There is a choice to provide IPv6. I'm not selecting that for right now. There is also a choice to get dropped down and get a dedicated VPC, which means dedicated hardware, which means more money. And that's a good idea for certain situations. If you have lots of money in a big company and you want dedicated hardware, you may want to get that. Nothing wrong with it. But for us, I don't think we need that. So we are going to choose default and not waste money. Having said, I'm going to create this VPC right now. So I click create. The VPC gets created. However, at this stage, we are still not accumulating any bill. No bill yet. The bill will come when you allocate resources like a machine or something you add, you will be charged for that resource usage. So for example, if you have a free trial available for 1 full year, you will probably get away without actually any charges. I will be charged for some usage. That's okay. So in that cloud, in that VPC that we have created just now, virtual private cloud, what I will like to do is, there are 2 of them now. One is called Cloud Genius, the other is called Ignore. So I want to really ignore the Ignore one. Otherwise, what will happen is there are lots of subnets showing up for no reason. These are the subnets that are actually allocated to the other VPC that I don't care about. So I want to filter and narrow down and focus on just my VPC that I'm interested in, for which there is this filter by VPC method. So I'll go there and actually click and select the one that I'm interested in. So I'm going to select the Cloud Genius VPC, click. And now my view is focused just on the Cloud Genius VPC. In there, I will see my VPC shows me only one. This one, the number is 62F7, whatever that number is. So that's an identifier number for my VPC. Now inside, I can see my CIDR block, which is 10.0.0.0/16, which I chose. I know it, but that's good. This is just the VPC created. let's now create this idea. So we have a VPC created. The range of sub addresses here are this range. Now in there, I would like to create a subnet. A subnet is basically a subset of this thing. So I'm allocating some range of addresses that will belong on this subnet. So any machine that gets created here will get allocated an address out of that smaller subset. So this is a bigger number. I will create a smaller number like 10.0.0.0/24. This is a subset of the whole VPC. And that is what I will create as a subnet. So this is a subnet that I'm just going to create. I'll create another one. I'll call this 10.0.1.0/24. So slight differences, very, very subtle differences here. As you can see, the difference is here and here. And that difference basically lets me identify which subnet I'm talking about. I can give these guys a name like cat and dog if I like, but that doesn't have a meaning to it. So I will not use these names. Instead, I will have my intended usage as a name. So my intention is to create this as a public facing subnet and this one as a private facing subnet. In the videos, you might have seen other names used like, border check subnet and application subnet. You can use whatever names you like. Cat, dog is good enough, but private, public, border check, application, any of these names that makes sense to you is a good name. The naming themselves doesn't dictate anything, except that it's just an indicator of a name. Having understood these pieces, let's go implement these and create two subnets with these names, public and private. So we go back here and in our subnet section, we will create a subnet and assign the range that we have in mind. We have a range of subnet for the public subnet. I would like to make sure that it doesn't go to the Ignore VPC, but the CloudGenius VPC. And in there, the overall range available is this 10.0.0.0/16. So I will choose a portion of that 10.0.0.0/24, smaller portion of the bigger allocated VPC area. And here I will create a public subnet. I should again repeat that just by calling it a public, it doesn't make it a public subnet. You have to do certain connectivity options to make it actually become a publicly facing subnet. So for right now, we are just labeling it, but labeling alone doesn't do anything. And I will create one more subnet. What I just did is I created this one. Now I will create this one. And for that, I will use this CIDR. So different CIDR block. Back here, I have a public subnet ready, create, and then this time private. And I will make sure that I'm not choosing the Ignore, but choosing the CloudGenius one. And then assigning a CIDR block 10.0.1.0/24. Now having done this, create. So I have two public and private subnet ready. Now I want to connect them. How do I wire them? So let's begin doing that. I need to be able to get a modem from a cable company or internet company. In the cloud context, this thing is known as a gateway. I don't have any gateway, so I need to get one. So I create one and I give it a name. Let's call it CGGW, CloudGenius Gateway, if you will. Create. So I created a gateway. The gateway became invisible for some reason. It is invisible because of the filter. The filter is tied to the CloudGenius VPC. So let's remove the filter for a moment. You will see that your gateway appears again and it is disconnected, detached. So we need to attach that to a VPC. Which one? Attach it to the CloudGenius VPC. So I'll say, yeah, attach. So it is attached now to the CloudGenius VPC, which is what we just did, is got a gateway connection, CloudGenius gateway. And this gateway I attach to the VPC, not to the public subnet yet, not yet, just the VPC. It allocates itself to the VPC. Having done this part, we will filter again to CloudGenius, narrow it down, and we have the gateway showing up in the list and attached to the CloudGenius VPC, which is nice. Now, comes the most critical part in this routing business. And if you're new to this, just listen and watch carefully. This, I think, is the most hard part in comprehending this whole routing business. And that thing is route table. We have a route table given to us already by default. And as usual, I will ignore this and label it as ignore and just don't look at it, ignore it. But now I don't have a route table. So I need a route table. Now, what is a route table? Let's go to the picture again. In our picture, we have two subnets, public, and let's look at the private later, not right now. In the public subnet, I have a gateway. I need to have a table. Let's call it a route table. A route table is basically a table, like an Excel spreadsheet table, whatever table you can think of, that defines routing rules. So where can you go and how will you go? Where can you route to and how will you route to? That's what the route table decides. So we need to have a route table for every subnet. So we'll create a route table for this and a route table for this. That's what we'll create. So let's create them. So here, create a route table. We'll call this one in the Cloud Genius VPC. We'll call this our public route table. Just again, assigning a name public doesn't make it public. It's created. It will create a route table. But again, we haven't made this association yet. We just created a route table. It's like sitting somewhere here. It has no idea whether it should be associated with this or associated with this or associated with something else or both or all of them. It has no idea. So we just created one route table and we will create another one like this. So create another route table. We'll just call it private and in the Cloud Genius VPC and create. So two route tables created. The cloud has no clue what our intentions are because we just created this and created, this route table, this and this, but there is no explicit intention that we call out that I need to associate this route table with this subnet and this route table with this subnet. I did not call it out yet. I need to make that association clear to the cloud. I need to let them know that I want to use this table with that subnet, this table with that subnet. I need to make that association clear. So we'll go to the subnets again. Look at the public subnet first and identify that it has 0 subnets associated, explicitly associated with nothing, 0 subnets. So what does that do now? I need to make that association. So we'll look choices available to us. It says you do not have any associations for this public route table. There is no association with any subnet. And it says further, the following subnets have not been explicitly associated with any route table and are therefore associated with the main table. Whatever. What I want to do is modify. Edit the route table association like this and say, to the public route table, please associate yourself with the public subnet and save. So now I have one subnet, the public subnet associated, one subnet, the public subnet associated with the public route table. That is the association. We do the same thing with the other route table, private route table, subnet association, edit and make the association with the private subnet like this. I want to associate the private route table with the private subnet and I save. When I save that, I see that this association is now available. One subnet, private route table associated with one subnet. And that subnet happens to be the private subnet. So now you have a clear idea. The cloud knows that this association is made good. It knows which table to use when you want to route traffic. Now let us fill the tables, the route tables themselves. Let's go back to the public route table again. In there, we have to read what does it contain currently right now? What does the table currently contain? So that is defined in the route section. What does the table contain right now? You can see it. It's there. It says this. Now let us read and understand what that means. It says destination and some number below that. It's a CIDR block. And target is local. So let's go read that destination. It says 10.0.0.0.16. This basically means the VPC we created. This whole thing has the CIDR block of 10.0.0.0/16. So it means the route table says you can traverse through the entire CIDR block through a local connection. The target is the local target. You can use a local connection to connect to anywhere in the VPC. If you want to go outside the VPC, sorry, there is no route. So nothing will go, and it doesn't even know how and where to go because there is no entry in the route table. It is currently limited to just this destination, which happens to be the VPC itself. So there is no way for it to find out and how do we go traverse to the internet worldwide. There is no way for it to able to do that. So now, what does the CIDR block for the World Wide Web, the entire internet? By the way, in IPv4, there are about 4 billion addresses. How do you represent a CIDR block like this for the World Wide Web, the entire internet? That is a very easy answer. The answer is 0.0.0.0/0. This is the CIDR representation of the entire internet in IPv4. So that is what we need to have as an entry in the route table for us to indicate that the internet is routable. I hope that is clear. And I'm going to expand the route table here so that machines on the public subnet should be able to route to the internet, because there is a new entry that we have to create in the routing table for the public subnet, which is the public route table. And so here, currently, there is only one route all within the VPC through a local connection. That is okay, but only limited to the VPC. I want to be able to go out. So I edit and add another route. And in here, I want to say that I want to go to the World Wide Web, anywhere on the planet, 0.0.0.0/0. That's where I want to be able to go. How will I go? Now, this is a good time to answer a question. What do you think I should put in the target? Look at this picture. I want to go to the internet. I have this gateway, and I want to go here, and I'm going to go out to the internet. So what do I put in the box there, here? I should put the gateway, right? Because that will allow machines on the public subnet use the route table entry that I am currently adding and send the traffic out to the internet using this entry right here. And in fact, it helps us populate that entry automatically. It knows that there is a gateway that can be used for this routing. So it pulls it up and shows up as a lookup item. We can just select it right there. And then we are checking this, that 0.0.0.0/0 means anywhere on the internet. You can route, provided you go through this target, which is the gateway device that we created. And it shows up just like that. CGGW, we created a step a few minutes ago. The same gateway shows up and we save our route. So it is saving. Now we have a route to the VPC through a local connection and a route to anywhere on the internet through the gateway. And this is the public route table, which is associated with the public subnet. So now any machine on the public subnet should be able to route the traffic to anywhere on the internet because of this new addition, which is the route that we added in the routing table for the public subnet. Now, having created this part, we now should create a machine. And what we have done is this public subnet, which has a routing table associated, and it says, you know what, local connection, you can go to 10.0.0.0/16, and internet connection, you can go through the gateway. So that is the route table we have for the public subnet. So if I now create a machine here, it should be able to route itself to any location like cnn.com, for example. It can go to that location just fine. You need to have a machine here, and just by the fact that it is on the public subnet, it will be able to route its traffic out to the internet comfortably. It also means that you can connect to this machine because it is routable and it is going to get a public IP, and you should be able to connect through port number 22 and go into this box and do whatever you like, SSH. So that's the scenario. Now compare this with your home scenario. You have a modem, and the first thing you connect to a modem is what? Is a router, also known as a NAT device. Now, how do we get a NAT device or a router from, say, here, Amazon.com, buy a router? Is that what I want to really do? Is I want to get this router and this one, that looks good. I want to mount this router in that VPC, in that public subnet. How do I do it? Is it possible? Can I take this router and ask Amazon to say, hey, use this there in my cloud? Can I ask them to use this? Like I can put it in my home. Can I ask them to put it in this subnet? Anybody? The answer is no. No, it is not allowed. You cannot ask Amazon to put a real hardware there. That's not allowed, not okay. So what do we now, how do we solve the problem? We need a router there in that location. In this location, I need a router. So there are two ways to solving this problem. And this, by the way, buying a router and give it to Amazon, that is not a way. This is not possible, not allowed. So how do you solve that problem? There are two ways. One of them is you build your own router. Or other one is get a ready-made router device, ready-made NAT. Ready-made NAT image is available in Amazon, or most clouds have it. You can also build your own NAT device very, very easily by adding like 2 lines of code in a Ubuntu box. You get a Ubuntu machine, plain vanilla, add 2 lines of code and restart the firewall. This machine becomes a NAT device. That's simple as that. And I'll give you an example of this later on. For right now, I just want to use a ready-made image. But then how do I find it? So let's go there in Amazon console, EC2. And I just switched, not in the VPC section. I went to the EC2 section. In there, I want to double check I'm in Virginia, and then I launch an instance. Here, you will try to find, it's not easy to locate. It's not readily visible. So you have to go hunt it down. It is in the community AMI section, where you have to actually search by the name NAT and enter to find some answers. You will find lots of answers for NAT. In fact, you can go and read what these answers are. So let's go read. It says Amazon, AMI as in Amazon Machine Image, VPC is in the Virtual Private Cloud, NAT as in Network Address Translation, HVM as in Hardware Virtual Machine. Year is 2014, September. It's kind of old. So I don't want to use it. So what I want to do is filter further. 2017. Let's get some later versions of the NAT. So here we got an example. Amazon AMI, VPC NAT, HVM 2017, April 17. This is June 17. This is April, March. This is, yeah, this is good. Looks good. This is recent, but it is release candidate. So I may want to skip it. I would rather choose a stable version. Maybe this one is 2016. So maybe not a good idea. So you have to go hunt it down. So here it is. Let's go. The best one we have available, I think, is this. Yeah, reasonably okay. So reasonably later. This one is even better. So here, 2017, August 12th. That was the build date for that particular NAT to be used in a VPC in Amazon, and it's a ready-made Amazon machine image. So that is the Amazon machine image I want to use. I think I accidentally clicked the wrong button. So let me go there again. I will search for community AMI and do a NAT 201708 to filter and narrow down to that same exact machine that I want. So this is the machine image that I want. The machine image ID is this. I want to use that machine. So I'll just say, use it, please. Select. And that's the machine I want to use as an image to construct a new machine and put it right here in place of the router, which is going to get in the public subnet, by the way. I want to place it in my VPC in my public subnet. I want to place that device in that location. So here, I'm going to select T2 micro size, small size, cheap size is good, no problem. Configure details. Now in here, I want to make sure that I am not using the ignore VPC, but using the correct VPC, Cloud Genius VPC. Next step, I want to make sure that I am putting this machine that I want to create not on the private subnet, but the public subnet. So I select public. Next, I want to make sure that I get an IP address, public facing IP address, automatically assigned public IP address. The default setting is disable. I want to make it enable. So 3 changes you have to do here. Select the right VPC, select the right subnet, public, for example, and enable. This is a critical thing to remember. You have to get an assigned public IP, otherwise this NAT device will not work. You cannot reach it. All those issues will pop up. So these 3 things are important. Rest of the details, you can skip. The defaults are good, no problem. We move forward, add some storage. I see that I am suggested to get magnetic disk. I don't like to get magnetic. I get GPSSD, general purpose SSD. That's the choice I will make. And next, 8 GB size is big enough, good enough. It's just a NAT. I don't want to store anything there. 8 GB is big enough, large enough, sufficient enough. So I will use that choice. Add some tags. I'm going to add a tag. And the name I want to use for this particular machine is, it is going to be my NAT device. So I'll say it is my NAT. That is my tag. I will configure security groups now. And I see that I have an existing security group, which is the default security group. And as you may have known by now, I don't like anything that is given to me by default. So I don't use it. Instead, I create my own security group. And the security group I want to use, I will label it as NAT. And the description will be NAT security group. Now in here, the purpose that I have in mind for this security group is I'm basically in my public subnet. I am creating a new machine using a ready-made Amazon image. It is going to be my NAT device. I'm getting a public IP here, and I want to be able to connect to that machine from my office like this, just like that, port number 22. And I want to allow myself to go there. So that's the security group I want to actually put in place. So the source for security group is my location, my IP. The destination happens to be this. The protocol will be SSH over TCP port number 22. I would like to allow the traffic. That is the security group definition. At the bare minimum is what I would like to have for the NAT device. At the very bare minimum. We'll expand on the definition later on. But at the time of creation, we need to call out that this machine belongs to the NAT security group, which currently will begin with only one rule, this rule. And so that is what I'm going to define here. I will say SSH access, TCP port number 22, allow me, just me, only me, nobody else, to connect. Because I have the private key, I will be able to connect and actually succeed. For others, even if you have a private key, if you are not in this location, you will not be able to connect because the security group will throw you off. Even me, if I take this machine to Starbucks and try to connect from Starbucks, it will fail. It will not let me connect because of my source IP is not matching this value when I am in Starbucks. It will be a different IP. So that is how you narrow down the scope of a security rule to basically go as low, as minimalistic as possible. So only you, only from your location, only from port number 22 through the SSH protocol can you connect. And you typically don't even want to connect to a NAT device. Most people don't typically connect to a NAT device, but we want to be able to. So that's why we are putting this rule in place. And it's narrowly focused. And with that rule in place, I will go to the next step to review the details. And I have the details understood. I will now launch it. When I launch it, it will ask me, hey, do you know what your key pair is? And I say, yeah, I know. I have the key pair in there. So yeah, that's good. I have the private key there. So I will acknowledge that I have the corresponding private key. And I will actually launch an instance. I just did. So that instance is launching. I'm going to view my instances. It will show me that I have this T2 micro machine with a name that I want to actually call it out as my NAT device. That NAT is actually starting up, pending. It is going to get assigned a public facing IP pretty soon. It already has a private IP. As you can notice, this is a 10.0.0 address, 10.0.0.192, which takes us to the point here. Our public subnet was 10.0.0/24. So in here, whatever you want, you can put in. So we got assigned this number 192, but the full address is 10.0.0.192. That's the address was assigned to this device in an internal address space. But we are not really interested in the private address space. We are interested in the public assigned address. This address is what I want. So I can connect to it. So I'm waiting for it to appear. So that address is coming up. Oh, it came. So we have a public IP address now right there. That is the IP address I want to use. And I want to connect to this NAT device. I would also like to check a couple of things here. For example, is it running? Yes. Is it in Virginia? Yes. Is it using the NAT security group? Yes. What are the rules? Let's check. The rules are TCP port 22, allow from my location. And permission, yes. Next, it is using the Amazon AMI VPC NAT HVM, the machine image I chose for NAT, for network address translation. So that's a good one. Couple other things here. It is using my private key IDRSA, which is exactly what I have in mind. Next one, it is the public IP address allocated and assigned to me, which is useful. And a couple other things here. The VPC ID 62F7. Let's go compare that. 62F7, is that the right VPC? Yes, it is. Our VPC, CloudGNS VPC is 62F7. So it matches. Let's check the subnet also. It is Delta Zero Brother Charlie. So this Delta Zero Brother Charlie, let's go see here and here. And the public subnet should be Delta Zero Brother Charlie. So it matches. So it is correctly located in the right spot. And we should be able to connect to this machine as soon as the initialization checks finish. So I'm going to get ready.
I have a question.
Yes.
Let's say you go through and you see some of these are not correct. Can you go back and create the NAT, or do you have to create a whole other NAT to match it?
Can you say again? Ask your question again.
The steps that you took, say you get to this final page and something is right. Can you go back to the NAT and correct it, or do you have to go and create a whole nother NAT to correct it?
What was the type of mistake that you may have run into? It depends on that. Like if you forgot to add your key, then you have to delete the machine, create a new one. Okay. But if there are certain changes you want to make, like security group changes, you can modify the group rules itself.
I'm not sure I put my IP where you did on that. And yes. I was wondering, can I go back on that NAT, find my IP, put that in, and make sure that's...
Yes, you can. Here is how you do it. So you have to go to the security group and identify the NAT security group.
Right.
And inbound rules and modify the rules. And here...
The source. Okay, thanks.
The source. You can delete that source and choose whatever source you like. So I can choose whatever I want. So I'm not saving this, I'm canceling it out, but you can choose the source for you.
I got it.
Okay. So having done this part, what we have to make sure that we do, and this is how you need to make sure that you are able to connect to the device first. So that's the first thing I want to check is go to that IP address, connect to it. Now here in our workstation, in the command line, we have the command line open, and I want to make it full screen and get ready to type. So something like this, SSH. And then I need to type the username. I know the username is, and this is not magic, you have to actually go read the documentation for the Amazon NAT AMI. The documentation will tell you that the username is this. And then the IP address. And then you have to provide the key, the private key, which happens to be located in this location. And here you can see that I have the private key that I'm passing as an argument. Now this will establish a connection from my location to the NAT machine using the EC2 user. This is the username for Amazon machines. Amazon provided images. Amazon likes to use the name EC2 user for usernames. That is their choice. So they tell us in the documentation and we'll just follow that. And so this is the IP address for the NAT device. This is the key pair, the private key corresponding to it. And we should be able to successfully connect to the NAT device right now, like this. And it says, do you want to connect? And I say, yeah. And it got connected to the Amazon Linux AMI. This is a Linux custom made by Amazon. It is a derivative of the Red Hat Linux. And it is connected to the NAT device as a EC2 user. Now, we succeeded. But we don't want to stay connected to this device. That's not the goal of this device. So we'll just exit. We come out of it, log out. The purpose of that device is to allow traffic routing, right? What does traffic routing mean? It means, you have public and a private subnet. You have this NAT device ready. This NAT device, the purpose is to allow this machine M1 and this machine M2 to let these guys go out to the internet. That's the whole purpose of this NAT device. It is not for you to go and connect to it. Of course you can, and you should at least check whether you can. But that's not how you actually use it. The usage is like using it as a router. So the route that for this routing table, for the private subnet should be defined according to what your usage scenario is. That is what we'll do next. So we have to now go focus on the route table for the private subnet. Now that we have our NAT ready, and actually there is one more thing. Just because you have a NAT device put in the right spot in the public subnet does not actually make it function like a NAT. There is a catch that you need to know and remember. And that catch is right here. It is this segment. Now this segment, what it does in Amazon is that it forces source and destination checks. Let's go understand what that means. It means indicates whether the source and destination checks are performed or not. Now for a device to function like a NAT, you need to disable this check. That is a necessity for NAT to function like a NAT, because NAT basically masquerades. It pretends to be you when it is not you connecting. It pretends to be M1 to CNN.com. When M1 wants to go to CNN.com, NAT will pretend and show CNN that I am M1. When M1 wants to connect to CNN.com, NAT will basically lie. Say, yeah, I am M1, talk to me. When M1 asks for CNN.com, NAT will say, yeah, I am M1, pretend. Masquerade. This I think you must have seen a video of me talking about masquerade. Masquerade is not the movie, but it is this. So you can see more about masquerade NAT and read about lots of other things. But bottom line, it pretends to be other machines. M2 wants to go to NewYorkTimes.com. it will pretend to be M2. This NAT will basically lie, say I am M2. And when you're doing that kind of a function, which is a rightful function for a NAT, that's exactly how it is supposed to be behaving, you need to disable source destination check just for this one machine. Only this machine, not for anybody else, just that one machine. You need to disable this check. Source destination check has to be disabled just for the NAT device. So this machine, I will right click, networking, and then in the network section, I will say, change the source destination check. So click. And here I have to disable, consciously say, please disable this check. And I will disable it. After I disable it, it should say source destination check false. Now your NAT functions like a NAT is supposed to be masquerading. It will successfully masquerade. That is now in place. Now that is in place, I want to now go and create this route table for the private subnet. How will I do that? Go back here. In this section, in VPC, into the subnet section, route table section, and there is the private route table. It is associated with one subnet. That subnet happens to be the private subnet. You know this already. But the routes are very limited. What are the routes? 10.0.0.0/16. It is limited to traversal within the VPC through a local connection inside the VPC. So it doesn't allow any route to the world outside. And these poor guys, M1 and M2, these guys, they are stuck. They have no way to traverse to the world outside and go to CNN and New York Times. So we have to provide this connection, right? The one that I don't have it yet. I want to provide that connection so that these guys, M1 and M2, can actually go and connect to the internet outside. How do you do that? You expand the route definition. Currently, it is limited to 10.0.0.0/16 with a local connection, meaning these machines can travel and access their VPC as a whole wherever it wants to. That's okay. But if you want to go to the internet, 10.0.0.0/0, there is no route. That's what a black hole basically means. This missing is a black hole, and we don't want that. Instead, we would rather put something in there. Now, what would you put? You can put this gateway that we have, Cloud Genius Gateway. And if you put that, it will allow traffic. But then it defeats the whole purpose of protection of your machines M1 and M2 from the public at large, because you're just exposing your machines directly on the public internet. It defeats the whole purpose of having a VPC and multiple subnets and security and NAT and all that. So you don't want to use the gateway here. So what do you want to use? You want to use the NAT. So you put this NAT entry here. And that way, you're telling machines M1 and M2 and their brothers and sisters, when they appear on the private subnet, that you please use the route table for this subnet, which lets you access the internet anywhere on the internet. But remember, you have to go through the NAT. So go through this device like this, not directly. That's the scenario. Now we'll implement that scenario right now. Back here, we'll edit this on the private route table. Edit. The current route is 10.0.0.0/16 local connection, only within the VPC. I'll add another route. I'll say, allow you to go to anywhere on the internet, 0.0.0.0/0. And here I get two choices. I can choose the gateway if I like, which will be a bad choice. Doesn't give me any security protection from the public internet. I want to protect my machines M1 and M2. So I should hide behind a NAT, hide behind this thing that I just created. So that shows up in the drop-down menu, and I just select the NAT device. And then I save my private route table. As soon as I save this, my machines M1 and M2 become routable. They have a way to connect through the NAT and then go to the world outside, CNN.com, New York Times, do whatever you want. So you can access. Now, machines outside cannot access M1, cannot access M2 because they are on a private network with no way to get a public IP. They are not routable from the internet. So you in your office cannot get there. Not possible. So how do you go there? You still want to go there. And that is what I will talk about next. So first, before we talk about going there, we need to first have them there. We don't have any machines yet. So let us create a machine M1 in our private subnet. It's very easy. You go here, go to the EC2 section, launch an instance. And I'm going to do it quickly, but I think you've seen it a couple of times already, so it should be convenient or at least easy for you to digest what I'm talking about. I'm going to start a new machine here, Ubuntu server, and say select. And T2 micro is good enough. So I configure. And here I say use the Cloud Genius VPC. Next, I want to make sure that this is in the private subnet, not public, because I want to create M1. So private subnet, machine number 1. Private subnet. And I make sure that I do not get a public IP automatically assigned. I don't want it. The default setting is disable, which is a good setting. I don't want it. I want them to be not connected to the world outside. So I will leave it disabled. You can also go and actually select disable if you like. That doesn't matter. Default is good. Disable is the default. Next, these other entries, you can skip for now. Their defaults are good. And we'll proceed ahead. Add some storage. In the storage section, add some storage. General purpose SSD is good. 8 GB is good enough for now. We don't want to actually store stuff there, but just get some disk. Add a tag. The tag I want to add is, I will call it my machine number 1, M1. And then I configure my security groups. There are a bunch of security groups already existing, 2 of them. One of them is the default one, which of course I don't want to use. The second one is the network address translation security group. That has a very specific purpose. The purpose is to protect this device. So it's a very narrowly focused function, and we leave that group alone. We'll create a separate group for these guys, M1, M2, and their brothers and their sisters, because they are going to run our application. Each one of them. It will grow and shrink as we need to expand. M1, M2, M3, M4 will go and bring more machines, reduce number of machines as we need to be able to scale our application set depending on user load, workload. So this M1 that we are attempting to create by hand right now needs a separate security group that is going to be responsible for managing our applications. So I will call it my application security group. And in there, to begin with, I will again go very narrow. And I will say, allow SSH access, port number 22, TCP protocol, and from my location. Just very narrow. And I will review and launch. And then launch. And then select my key pair, acknowledge, and launch the instance. The instance gets ready. The machines are now visible. There is one machine called NAT and the other machine called M1. Those 2 machines are going to be available soon. This one is pending, initializing, and I am expecting to not see anything in the public IP at all whatsoever. Not getting it. Don't want it. Don't get it. Nice. But I have a private IP, 10.0.1.92. So what does that give me here? 10.0.1 and then 92. That's the IP address that I have for M1. it actually fits into our scheme of things for that subnet, the private subnet, 10.0.1 dot whatever. That range that we have was denoted as a CIDR block notation 10.0.10/24. This is the CIDR block that represents this address space, which is what is used to construct this entry in here. And that is M1 assigned. And that's the IP address we got. That is the private IP right there. You also have a T2 micro size running the application security group. The inbound rules are 22 TCP, connection from my location, allow. There is an Ubuntu OS underlying image. There is a key pair ID RSA. Source destination check is true, which is good. Keep it like that. The VPC is CloudGenius VPC and the subnet is private subnet. The machine is now up and running. How do I connect to it? I cannot. There is no way to route to it. So I don't have a public IP address. So I cannot really go there. But figuratively speaking, you can. And I'll show you exactly how you may actually go. So in concept, you have a private and a public subnet. You have a machine here and a NAT device here. You have a gateway here. And you can route to this, but you cannot route to this. Not routable. You still want to go there. So how do you do it? You can jump. Say again?
Port forwarding from the NAT.
Port forwarding is one approach. I would rather not bother touching the NAT at all. I would leave it alone. The way to think about these things is to not mess with a machine that has a dedicated purpose. So you have a NAT device, you leave it alone with that one function is to masquerade traffic for machines inside. That's it. That's the only purpose. Ideally, you don't want to even connect to the NAT like this. There is no need to. So the idea that you think about is, give one specific set of purpose for a given machine, a given application, a given service, and leave it alone. If you want to connect to this infrastructure, you should have a separate box dedicated for that purpose. And we will call that box jump box. Jump box allows us to jump from wherever we are. We connect to the jump box. It sits on the public side, and it let us jump from here to there. And so in principle, I would not use this box at all, but instead get a separate box dedicated to that function of jumping and use that as a jump, as a hop to go here or to go wherever else I like, or maybe another subnet, or maybe 3 more subnets, or whatever else you design. It's up to you. But a dedicated box to jumping is a good design idea. Some people call this jump box as Bastion. Other people will use the name tunnel. They all basically mean the same thing. It is a box that you use for temporary purpose of hopping onto these guys. It's a stepping stone. And in SSH, there is a method called SSH proxy command. This proxy command method actually allows you in one single step, without even having to run SSH here, you just go one command with 2 hops, go boom, boom, go all the way to M1. And that is an example provided to you already in your CloudGenius workstation. That is the right way to do things. So the proper way to do things is a dedicated box like jump box, Bastion box, tunnel box, whatever you call. But practically, it is not necessary. We can actually use the NAT as a jump box and save money. If you're a small business, you may not want to have this jump box, but instead you can save, which is not a good idea, but possible, technically possible to jump like this and use the same protocol, SSH proxy command, and jump through the NAT and go inside. We are basically assigning multiple purposes of jumping as well as NAT to the same box. So which is okay. Nothing wrong technically with it. It's just that philosophically, companies tend to have one role to one box and just dedicate it that purpose and leave it alone. You don't want to mess with your NAT. Because if you happen to make a mistake, you are venturing, your people are coming into the device, they might make a mistake somewhere along the way. You don't want to have that. So you dedicate a simple machine, just focus it on one purpose in life, which is NAT, and leave it alone. The other box, jump box, you can start it up if you like, connect, play around, mess around, come back, and delete the box. That's the way to deal with it. So you just get rid of the box. If you don't like it anymore, don't want to go in the VPC at all, just come out of it. That's one shortcut way of getting into a VPC in the machines inside M1 and M2 and things like that. There are many ways to solve this problem. This is just one of the ways that I am suggesting that we go. So for right now, having described this idea of a jump box, and I hope you understood why the two functions need to be separate in a separate box, I think we can get away with just using the NAT box for now. So I'm not really going to create a separate box, but I just described the idea that is important for you to know. Don't mix multiple things in one location, one box. It's generally a bad principle. It works technically fine, but a bad idea to begin with. We'll still do the bad idea because there's no point actually after having understood, there is no need to create a jump box. We are not a high-end production game right now in this scenario. So we don't need to have this for this specific exercise. We'll skip it and just use this one as our stepping stone. Now that we have this machine ready and a way to connect to the machine directly, we need to somehow have a way to connect to this machine with one command sitting here on the workstation. And just run the command. It should just take us all the way there. That's what I want to enable. So that is in an example readily available to you in the workstation here. If you now look at the location called SSH, you will find a file here. The file is called config.example. That is the file I want you to edit a little bit and use it as a stepping stone into your M1, M2. So let's go see that config example. So we'll cat config example. And you will see here, there is a reference to a jump box. There's a host name for the jump box itself. And then it is forwarding the agent that you are passing along from your local machine to the jump box. And then through the jump box, we are proceeding further ahead to the machine inside, which is this. The machine inside in this example, we need to modify those IP addresses because they're not accurate. They're just an example. So we'll go modify this particular file. You can open Atom Editor here and modify that config example file that looks like this. And so in that location, we have to grab the public IP of the jump box. First thing. So we'll go here, grab the public IP of the jump box we have in mind is I want to use the NAT device as a jump box. So I'll grab its public IP. I got that, copy. And bring it here and paste. So now I have the correct IP address for the jump box, which actually is a NAT device. I can relabel it as a NAT device. So it has two references here, jump box, jump box. I can maybe call it NAT because that is the one that we are using right now. You can call it NAT, call it whatever you like, I don't care. Next, the username for the machine with this IP address happens to be EC2 user. So just you have to use that correct username. If you're using another type of machine, you have to modify the username. You have to also provide your identity file as a reference. This is the private key that you use. And now you want to go to the machine inside. This is the M1 IP address. So in our case, the example IP address is actually slightly different. I think it is 92, if I remember right, but I'll confirm. So it is 10.0.192, and I'll confirm that. With the M1 machine, we don't have a public IP. We do have 10.0.1.92. And that is what I want to make sure that I have here, 10.0.1.92. Good. And now comes the proxy command. This proxy command is the line number 9. And that is what will we'll see it in action. So it will better to understand in action. So we'll run this command and actually see how it works out. You will also see the very last line, line number 12, is the user for the machine M1. Inside the machine M1 we have is a Ubuntu box, and the username is Ubuntu. With these changes made to this config example, I would like to save this file and close it out. Having saved that, I would like to rename the file, or rather copy it. So copy the file config example to just the name config. This example is an extension I added, which is not really the extension I want. So I don't want the dot example at all. All I want is just the name config. When you have this file name, then you cat it and confirm its accuracy, which you do, and then you come outside of that folder, SSH. You are out. And once you're outside, that's where you are able to now traverse all the way to the machine inside with a command I will now walk you through, but step by step, watch it. First thing first I'm going to do is remove the known host file. Having done that part, I will now attempt to connect. Simply like this, 10.0.192. Now, is that address routable from my location? No, not at all. But the fact that we have a config example in place, the config file in the .ssh folder in place, which looks like this, you know this file exists. So now that it exists, I can actually route like this and watch what happens when I enter. It will show us those two hops that I was talking about, first as a stepping stone to the jump box, which happens to be, we are using the NAT machine, which is this name that I have chosen here. This name is not important. The IP address is important. So as a first stepping stone, this command that I'm going to type, that I just typed, I'm going to press enter now. You will see that it attempts to make a connection with the public IP address for the NAT device, this address. And let's see what happens. So it attempts to establish a connection with the NAT machine. Say, hey, do you know what this thing is? Do you want to make a connection? And I say, yes, yes. So I say, yeah. And so when I say yes, what happens to the known host file? Let's go check that. So I'll go open a new terminal. And in here, I will cat my known host file. The file doesn't exist quite right now. It's not there yet. So as soon as I say yes, the file gets created. And I think I must have made a little bit of too much time talking, so it is going to time out on me. So I'll have to break on it. I think I spent too much time talking about this thing as opposed to letting it go forward with a yes. So I will have to break and do it again. So breaking and removing that known host file one more time. Checking it doesn't exist. Yeah, it does exist, by the way. So there is this entry that popped up because of the yes that I said, but it then timed out because I was talking too much. You're not supposed to be talking. You're supposed to be saying yes and proceed forward. Otherwise, it times out and blocks you out. So removing the known host once more. And this entry that you see, this known host entry, is the entry corresponding to the NAT machine, because I said yes in the previous step in the other window. So I remove that file again and attempt again, this time go quicker and say yes. Now it will attempt to route to the machines inside, go in and fail. Do you know why this will fail? Because of security groups. Let's go understand our security groups very carefully. They're very, very restrictive, very, very narrow. Let's go read that. It is going to fail right now. It doesn't even know, it gets blocked at the security group layer. And we'll watch the security group for our machine M1. We are not able to go there. The traffic is routable, but not accessible, because the inbound rules allow for connection only from my location, but we are actually connecting from the NAT. So this security group has to be expanded in scope a little bit. How much? It should allow connection from the NAT to the M1 machine. That connection is prevented. Even though traffic is routable, permissions do not exist from a security group perspective. So that's why it is not letting you unless you modify this security group called app and then expand its scope. So we go to security group section, we look at our app security group, and we expand its definition. Currently, the inbound rules are, you can come in as long as you are coming from this location. In our machine here, we are coming from the NAT, this location. And so we need to expand the scope. How do we do that? We say edit the inbound permissions and add another rule, allow SSH access. Where is SSH? There, SSH access. Allow it, oh, custom, no, SSH access, allow, but the location should be the NAT security group, right? Anybody in the NAT security group? That's what I want to say. So as long as the security group is, you just start typing NAT, you don't even have to go hunt it down, the security group identifier. You can type SG like that, and it will pull out all the available security groups that you want to choose. And you want to say any machine that it belongs to the NAT security group should be allowed to connect to the application machines M1. And that is the custom rule I'm adding in, which says custom SG NAT. And this identifier maps to the security group for network address translation devices. And with that expanded definition, there are two parts to it. One coming from my location, this location. And the other one is the security group for network address translation. With this, I will save and then attempt again. It said, SSH exchange identification connection was closed, which is fine. We'll just do it again. And this time it will say, do you know what this thing is? 10.0.192? I have no idea who this thing is. Are you sure you want to connect? And I will say, yes. The moment I say yes, it routes all the way through and through to the machine inside and lets me get to my Ubuntu box with a 10.0.192 address right there. 10.0.192. And I am connected to the Ubuntu box. Now let's do it one more time to clearly understand the known host issue. I mean, there's no issue, just known host situation. So here we are deleting known host again. And this time, exit out from here and SSH connection one more time. It will say first, connect to the NAT. Are you sure? I say yes. It will connect. Now ask the same question to the other machine. Are you sure you want to connect to M1? I say yeah. So it goes. Without me having to provide a copy of my private key in the cloud. My private key is still local with me. I did not send my private key to the NAT machine. All I did was exit. All I did was cat.ssh/config, and I am passing my agent. I'm forwarding my agent from the NAT machine to this machine and allowing the SSH proxy command to function, which is basically another SSH execution through the NAT machine onto this machine using the locally available private key. That private key does not go to the cloud. In practice, you can actually copy your private key over to the NAT box and then skip out on this proxy command business or SSH config business. You don't have to do it. But then you violate another principle that you just let go of your private key. You put that in your cloud. Bad idea. Should not. There's no need to. So this is one way to hop through a jump box, and we are just using the NAT device as a jumping box, which is not supposed to be in a production situation. Don't do that. But you could. Technically, it's possible. So we jumped like a hopping stone as a intermediate point and then get into M1, and that's how we routed. With this done, let us now see, can M1 connect to the world outside? We talked about it all along, right? We've been talking about it like ever since 4 o'clock. And it's, I want to check whether my machine M1, which I'm connected to right now, maybe not right now, now I'm connected to that machine M1 can this machine connect to the world outside CNN.com? Let's go say ping CNN.com and it will fail. Do you know why? Because the traffic is not routable. Our security groups are so strict that nothing is routable. Nothing will be allowed. It knows the route. It figures out the IP address, but it cannot actually send a ping packet because of security group restrictions. So let's go see the security groups again. Now what we are trying to do here is the application security group. This is trying to go through the NAT to the world outside, right? So we need to allow that traffic. What traffic do we need to allow? For NAT to let people come in from M1. Let NAT should allow M1 to send traffic into the NAT. That is not allowed right now. If you look at the NAT security group, its inbound rules are very, very limited. Just me from my location, get into the NAT box, SSH protocol, port number 22, done. Nothing else. It's very restrictive. I said, I want to have my machines, where is that? Here, these machines, I want them to be able to connect to the NAT, right? So that NAT policy, NAT security group should allow that connection. Coming from M1, coming from M2, coming from anybody here, please allow. That needs to happen. Otherwise, it will not go forward. There is a chat question here, apparently. The chat question is, does that mean any IP in the subnet associated with the security group? No, no, not any IP. You have to call out exactly what you mean to put in the definition of the security group. Very, very specific. And the more specific you can get.
I was just noting when you said in the routing table, I think that's where it was, where you could put in an IP address or a CIDR block or a security group. To allow that.
Not in routing table. No, not in routing table. Let me check. I think routing table doesn't allow a security group.
What was that?
It's in security group. You can put another security group. Yeah.
Yeah, it was pretty cool. That was easy, I guess.
Yeah. Yeah. So here I'll show you that example of this NAT security group. I will allow, say, all traffic. Where is the all traffic? All traffic. I will allow all traffic provided it is coming from all traffic allowed provided it is coming from the application. As long as it is coming from the application, that is the source, allow all traffic. Let people do whatever they want. They are internal people. So I'm saying custom app. This one, that security group itself, anybody who is in the member of the application security group, they're basically M1 and M2 and their brothers and sisters. Let them go. Let them do whatever they want. All traffic, permitted, go. So I saved it. Now, back here. See, ping started. You see, pinging started automatically as soon as I opened up the security group. The ping was pending because it was not pingable. It was routable, but traffic would not actually flow. Traffic flows when you open the door. And I just opened all traffic allowed as long as you are originating from the app security group. Do whatever you want. And so it does. And it's pinging comfortably. Now I break it. So that's the concept. I think at this time, we should take a moment to break and breathe and digest this. And because this is, I think, one of the most complex things in the first segment, cloud technology segment, is to be able to understand routing, understand subnets and the route tables and, security groups and all the little things. There are so many things, so many variables here involved that they need to be understood. And if you don't get that, it's hard. So I'll now take a break. Here, timer starts.
Nalish.
Hey.
Yeah, this is Jim. So on that exercise that we did prior to this, I checked my security groups and they were for outbound rules. We hadn't done inbound rules as part of the exercise. Is that what you just did, though?
I did inbound. Yeah.
Yeah. Correct. Okay. That was the difference. That's why
outbound rules are basically lax. You let people go wherever you want. There's no reason to prevent people from going out. There can be, but currently in our examples, there is no reason to prevent people from going out. And that's why our outbound rules are basically open. Let people do whatever they want. Let machines go wherever they want.
I understand now, because I went and checked my inbound rules to check that my IP stuff, and there are no rules set. And I went, oh, now I get it. Those were all inbound.
Correct. Yep. So let's go see that again. I think.
One reason for using outbound rules.
Yeah. Let's see if I can get that screen. I think our rules are focused on security groups, and the NAT security group outbound rules are all traffic go anywhere you like. Applications, same thing, all traffic go anywhere you like. So outbound rules are pretty lax, very, very easy, open. It is the inbound that is critical, right? You have to narrow it down. And like I just did. And for the application security group, by the way, you can further narrow this down, and you don't need to provide this address at all in the application scenario. You don't need my location at all. Save. Because you're allowing access from the NAT device, there is no need to get to my IP to get directly to the application security group, because first of all, there is no route. And then there is no need for that entry. So in fact, this will work just fine without that rule. And here it goes. So it goes straight connected to the Ubuntu box, one step with a hop in between. And now we are connected. We can go ping, and ping should function just fine. You can even run updates, like, apt-get updates, like sudo apt-get update. And so it is going to go to the Ubuntu update server and bring down updates for the machine if you like. That's the dominant usage scenario for machines to go to the internet, is to basically get updates, or sometimes access simple storage service or some other service from outside, access some externally hosted database service, something like that. And so it is downloading Ubuntu updates, installing them on the machine M1, because it is able to go outside through the NAT. I think timer, I think it's gone. So it's set 0 and closing it out. So let us focus on making sure that we answer questions. So I'm going to ask questions at this moment, if you have any. And I would like to see if you have a way to let me take a picture of all of you on the webcams. Is it possible for all of you to please open your camera so I can take a picture? If that is possible, if you are, maybe I'll give you some time to get ready, and if you want to dress up or something, take your time. But I want to take a picture basically. Yes. So take your time, get ready. When you're ready, maybe in the next few minutes, I'll take a group picture of all of us in the video conference. That will help. And of course, we are meeting face to face, so we'll do that as well. So whenever you're ready, you let me know. I'll click a picture, and then you can shut off your cameras if you like. It's up to you. And so thank you guys. Brian came online. John is hiding. And Tammy is also hiding. Who else is here hiding right now? Tammy is hiding. Tammy doesn't even have a camera, apparently. Today, she doesn't have a camera. And
chili up here.
I know.
Chili
is good. Yeah, I just had, yeah, why not? So I think we are ready to take a picture with whatever we have. So here we go. Let's go take a smile. 3. Look at the camera, please. I should look at the camera, not at the keyboard. So here we go. Ready? 3, 2, 1. I just took a picture. I'm going to post it in Slack chat so we have it. And it's coming down in Slack. Let's see how it came. Slack chat and group chat. And where is the screen sharing option? Start sharing my screen, share the screen, and you should see my, where's the desktop first? Desktop, hide curtain. And there is the group picture that I just took, which looks interesting, absolutely. And I'm going to drop this into Slack chat. So you have a copy. And here we go. So it is coming in 3, 2, 1, go. There it goes. Now let us continue. First of all, focusing on the questions that you might have with what we did, because it was quite a bit, I would say. It's too much sometimes to digest. And many of us are doing it first time. So it is kind of that challenge in place. So I want to make sure that you really, really understand. The critical things to understand here are two. One of them is the routing table. And second one is your security group scenario, the inbound routes and outbound routes. That concept, I think, has to be very, very clearly understood. And if you're good with those things, we can move on to other exercises. Not that big a deal. But if you want us to spend a little bit more time on these two aspects, the routing table aspect, which can be clumsy, and the security group aspect, which is conceptual. And one simple way to think about security groups is less is more. Narrowly focused groups are very, very secure compared to broadly targeted, focused, rather unfocused security group rules. Narrowly focused as in you have to have a very specific purpose in mind. I want to allow this packet to flow from this location to that location. So I will open exactly that portion and nothing else. Yes.
Are you drawing things?
No, I'm not. No, I was not. I was just, thank you for reminder, but I was not drawing. I will draw. I will actually get my screen and get my pen and draw these things because that is important. So,
question, when you pulled up those two sets of command, you had one that was labeled NAT as far as the host name, and the other was Ubuntu, and you had an IP address for that. I missed where you grabbed that IP address from because you changed it.
Okay, I understand. Let me quit this portion. I think I started an update for no reason. So let me keep the local version installed and let this finish. And I'll come out of that thing and then ask you this question. What are you talking about? This?
Not that one, the one before.
You mean this?
Yes, okay, the upper one. It says host name. That you grabbed that from somebody because you said at first it was wrong, the host name, and you grabbed it, and I missed that. The dogs were going crazy because somebody...
Correct. No worries. So this is the public facing IP address of your device, the jump box.
Okay. The NAT, we're using the NAT, but we're calling it the jump box. I got it.
We are using the NAT, but our purpose in mind is jumping.
Got it. Right?
We want to jump. We want to use the NAT as a shortcut, as a bad shortcut.
Right.
It's a bad thing to do, but you're doing it because technically it's possible.
I got it.
If you have a jump box, for example, if you have a properly configured jump box, I would go something like this. In that situation, what I would do is in the config, I will not use the name NAT. Instead, I will say, jump box. And
Gotcha.
I will not use this IP address, but actually use the real IP address for the jump box that I have it dedicated for this purpose of jumping. I will also include a generalized rule about these machines that I have inside M1, M2, M3, M4, and expand if say I have another one. So let's see, hold on. I have another machine here that I will like to call, say M2. So this was about M1. This segment is M1. So I want to get M2 in place. So what I'll do is get the M2's IP address. So say it is 94. And that is my M2 connection. I can keep adding segments like this. And say this is my M3. And like that, I can keep accumulating those details in a list of things that I want to be able to connect internally to my cloud in the private area. If I want to have a shortcut, I will say asterisk. So I don't even have to type these things. It just picks up. And this way, if you have more machines with the same subnet, you can just collectively route to them if you like. So that's the concept behind this kind of a usage of a config example file, which I rename as just config. The name doesn't matter. You can call it whatever you like. Oh, sorry, not it has to be single word. You can call it whatever you like. And the host name should be the one that you have that as your public IP. And these are internal addresses for the private area. That's the concept here. This is just one of the ways you connect to machines inside. Having done this part, there are other ways to establish connectivity to a private area. And that is dominantly the other way people use, which is to actually use a VPN connection. The one that I think we discussed briefly in this example, where you, excuse me, where the wizard actually lets you connect through a VPN. So this scenario of establishing a VPN is what is dominantly used in corporations most of the time. This simple example I just illustrated to you is a beginning step towards building a more complex solution. VPN used to be hard, really hard. Now it is like a few lines of code and you can get a VPN functioning in your cloud. To get a VPN functioning in your cloud, what needs to happen is something like this. So let's go play with that scenario. So we have a white sheet of paper. We have up until now what we have is this an M1 here and a NAT device here, and we have a public and a private subnet. We have a route table. We have a gateway. What else we have? We have some security group for this guy. We have a security group for this guy, or rather these guys. What else we have? That's it, right? That's what we have constructed up until now. Our routing is defined as you go through the gateway and you go through the NAT. That's how the routing is structured. The security group rules dictate what traffic can actually flow. Routability and traffic flows are two different things. These things control the routability of the address space, and these things control traffic through the firewall system. Now, having understood these pieces, and we jumped from our office location through a hop SSH proxy command and connected to this machine, no problem. Now we will introduce this. So concluding this topic, we have this idea of a jump box that I think we should use in practice, not touch the NAT device directly. So touching NAT is generally a bad idea. You leave it alone. And so in practice, in real life, you would connect through the jump box and then go wherever you like. That's one way of using. The second way of using is to avoid this SSH config business, which can be difficult for a large scale. Like, so what do you do now? You deploy a VPN server right here. And you let your company employees, the other guys, everybody else, you can have these guys connect through the VPN, or rather connect to the VPN, and then the whole cloud, the VPC, this whole thing becomes routable easily because of the fact that you are now connected to VPN. So for those of us who have never used VPN before, let me give you a very simple way of thinking about a VPN. You have a cloud and you have some machines here, M1, M2, M3, and route, subnets S1, S2, S3, and lots of stuff in there. And you have a VPN server. This is your subnet 1, subnet 2, subnet 3 with machines M1, M2, N1, N2, and P1, P2 machines. Lots of machines, lots of subnets. And you happen to have a VPN server also. And this is your company, and you have people in your company. And what happens is, some of you people in your company are in Starbucks, and some are in the corporate HQ. And so the idea that we have, as soon as these guys in the Starbucks location, or maybe home location, your employees in your home, as soon as they connect their laptop to the VPN server, something happens, which is what I would describe it as logically placing the laptop of this person in here. That's what happens, practically speaking. It doesn't physically go there, but you logically place your laptop inside the cloud, inside that secure area. The same thing happens. Your Starbucks, you have a laptop and you connect to the VPN server. What you're really doing is logically placing your laptop in here. So as soon as you have logically placed your laptop inside the cloud, you can connect to whatever you like. You are already in the cloud there, logically, not physically. Physically, you're not allowed there. Same with these guys, corporate guys. You establish a corporate point-to-point VPN connection. Thereby, you're logically placing all the machines in your company right here in the VPC. So it's like logically right there in the private network, which means all your employees, these guys, can just connect to any of the things that you like, and it's just there. I mean, it's easily routable. You need to still have security group permissions, but apart from that, it is routable. So that's what a VPN server does for us. Now, VPN servers are used to be really complex, and Cisco and Juniper will sell $100,000 and all that good stuff, but it is open source, available right here. This gives you a VPN solution. How do you use it? Using this is hard, used to be hard, but there is a simple solution that is available in GitHub that we can deploy very easily, and that is, what's his name? Kyle. So this guy has developed a very fantastic, good solution for Docker use of OpenVPN. I think it is this product. I think it is this one. Yeah. So what happens is, you need to have a box, not specifically any box actually used. So I'll exactly advise how. So in our example, public, private, M1, NAT, jump box, VPN server. That's how you should allocate a dedicated box just for the purpose of VPN. That's what you should do. And if you're using a VPN server, you probably don't need this, so you can get rid of it. So it goes away. But in practice, you keep a separate dedicated box that would run Ubuntu or any Linux. And then you configure this box, first of all, as a Docker host. Once you have Docker running a VPN is one line of code. That's it. That's all it takes. And so I have this setup functioning. It takes a little bit of time to understand Docker and to understand the idea of running this particular piece of Docker code, which is what we have here, OpenVPN for Docker. We will run this, but we are not ready for it because we haven't discussed Docker yet. So that's a building block towards it, which will make it super easy to install. So just this quick start should actually finish off setting up a VPN server. And the idea would be, first thing, get a box, then convert it into a Docker host, and then run this Docker image on top. And that makes your a VPN server just like Cisco and Juniper would do. And then you create credentials for your employees, distribute it to everybody, and they should be able to just VPN. no problem. Now to save money in a small situation, you don't really need this technically. Technically, you can just use the NAT device. Actually, just like we have been cheating all along, use the NAT as a jump box. You can use the NAT as a VPN box also. Totally possible. And so as long as you are able to run Docker here, which I think we can, we should be able to run Docker first and then install this Docker image on top to make that NAT also function like a VPN server. Now, this particular VPN software called OpenVPN requires a specific set of ports. The port number is 1194. That needs to be open on UDP protocol. Not UPD, but UDP. So UDP port 1194 needs to be open from public access, from outside, should be able to go in. So we had to edit the security group for NAT security group and open port number 1194 UDP to allow for traffic from our location. And then we should allow these guys in our company to connect to the VPN server. And then they are all able to route to anything in the cloud, M1, M2, maybe there are more machines out there and more subnets and everything else. All of it is routable because they're logically placing themselves. This machine that they have is logically placed inside here in the VPC. So that's the step that we need to build towards. So in our NAT box, let us see what does it take to get Docker to run. And this is something that I want to, before I jump into that exercise, which I have never done before, by the way, but that's okay. That's not a big deal. I have never run this Docker OpenVPN on a NAT box. I have run it on Ubuntu many times, not on a NAT box. So we can either set up a separate box and not run into issues, which I think is a very radical, very rational approach. Running this on a example that I have never done in before is probably not a good idea. So I will not venture into the direction of running this example directly on the NAT box, although technically possible. By principle, you should not do it at all. You should always dedicate a separate box because that's a separate function, the VPN function. It's a different role, different purpose in life. It is not the NAT function, so don't mess it up. That's what I would suggest. In production usage, you keep it separate. For messing around, totally okay. Totally okay. And I don't want to actually mess around right now because I might make mistakes because I have never run OpenVPN on a Amazon NAT machine. That is what we have it running there. I've not done it before, ever. So I don't want to make mistakes. Although I know how to get it done, but that's not the point. I want to actually show you a functional example so you can put to use. And therefore, I am going to create a new box here. Convert into a Docker host, and then throw this image on top, and we get an OpenVPN setup. We'll use it, and we'll configure from our locations in our offices. Each one of us can get an access credential and make a connection like that. Connect and route to M1, to M2, to whatever else we have easily, no problem. That is what I will be doing next, and not mess up, or rather not mess with this guy, which I've never done it before. That's the reason, the only reason I'm not messing with it, because I don't want to waste time debugging here. I can do debug later, but not with like 10 of you listening to me. So I don't want to debug like that. I'm okay with debugging, but not wasting your time. So that's why I'm creating a new machine, which is also, by the way, a good idea to separate roles. And we'll now create a machine. So we'll go to EC2, launch an instance, launch an Ubuntu server, and T2 Micro is good enough for just experimentation. It is not good enough for production usage. It is too small. But for us, it's probably okay. Cloud Genius VPC, and I want to select the public subnet because it should be routable from outside. The VPN server should be on the public subnet because I want to connect to it on port number 1194 UDP. That is our goal. So we want to be able to reach out from outside, from our company location, from Starbucks location, from our home location, wherever we are, to connect to this VPN box, which will be basically Ubuntu at the bottom, at the foundation. So that needs to be on the public subnet. So that's why I select public subnet. It needs to enable a public IP. That is also critical. I want to assign a public IP. So I enable that. And now rest of the details are okay. Defaults are good. Add some storage. 8 GB hard disk is good enough, big enough for VPN, no problem. Add some tags. I'll add a tag here. And there we go, VPN. That's the tag. And add configure security groups. Now here, just for clarity of my mind, in terms of what rules am I putting in place, I don't want to mess up the NAT security set of rules or the application security set of rules or the default, which I don't even want to touch. So what do? Create a new one like that and give it a name. What is the name I want to give? Obviously, it is going to be VPN. VPN security group. That's the name. And I know that I want to connect to this machine because I want to make this Ubuntu box into a VPN server. It is not a VPN right now. So I want to connect to it first with SSH protocol from my location. So I add that rule and I add one more. That rule is a custom rule. It is not in drop down, not available. Or maybe it is. I don't see it. So custom rule, it's a custom UDP rule, by the way. And I want to go to port number 1194. And that needs to be from my location. You can actually open it up to anywhere because we will have employees in the company. They are wherever they are. Sometimes they're traveling. Sometimes they are at Starbucks. Sometimes they're home. So it's okay to expand this to anywhere, provided your company agrees. So anywhere access. 1194. This is a protocol defined in OpenVPN software. That port number 1194 is chosen by the software. So you need to open that port. And this is why it is selected as the port for UDP access, which is how OpenVPN connects. So we are expanding we are adding these two rules. One for SSH, for me to go and actually make that box into a VPN server. And then 1194 for allowing our company employees to connect to the VPN that we just create. And we review and launch. And we launch. So it gets a machine created. I will create my IDRSA key pair and I launch the instance. The instance is ready and getting up and running. I'll go view my instances. I see that I have 3 machines now. One of them is the NAT machine, the other one is M1, and this third one is the one that is getting created. I will label it as VPN. And that machine, I need to get a public IP. Its source destination check needs to remain as is, no change. Don't make it false. Leave it alone. Our rules are simple. Let's go check the rules again. Our rules for VPN, the rules for inbound access are 1194 UDP protocol from any location and port number 22 just for me. So I can make that box, the Ubuntu box, into a VPN server. I will create that right now. Waiting for it to initialize, finish checks. And then this is my VPN server IP address, public IP address for the VPN box. I copy it and put it in a notepad. So that is my IP address on the, and this is by the way going to answer this question about how do they implement the VPN connection. That's the question I think Travis had. So that is what I'm really trying to answer as well as we build. We have to basically build a VPN server or spend money and ask Cisco to build it for us, either one. I think building ourselves is a much better option. It is free, open source, we control it. So that's the IP address for the VPN server. We have it handy. We keep it with us. And we will now continue along the journey of connecting to that box. So we will go read the documentation, what is needed. This is the software I want to run. It requires Docker, right? So we need to have Docker first. So we need to get Docker first on that box. So I will install Docker on that box as soon as I connect to it. So here I am going to connect to that box. How do I connect? Simple thing, SSH Ubuntu at IP address, and then my parameter to pass the private IP. That's how it connects. And I'll say yes. So now I'm connected to the machine that is going to become my VPN server. Not right now. It's going to become. And I am there. And let us see if I can route and we ping something. Can I ping something? Ping Yahoo. Can I ping? Yeah, it is pingable. Nice. So now let us see if we can update. Can I update? Looks like I can. Nice. So I am now ready to install Docker on it first. How do you install Docker? So you go to get.docker.com and there is a script. You take that script like this. And in one line, you install Docker like this. It will, oh, I should say sudo. Maybe I did a typing mistake or what? Curl. Oh, there's another step also. So the other step is this. That's the next step. So this is the next step. Unable to resolve host. I think it is doing it. It is functioning. I had to wait for it to finish, and I think it did. So it succeeded in installing Docker on this machine. I need to run this command to finish off the action expected. And that's what I'm doing right now. And I think I should have Docker running. Okay, permission denied. Maybe I need to log out and log in. Yes, so Docker is running now. That means we have converted our machine, Ubuntu, into a Docker host. It can now host Docker containers. Having get this thing in place, I want to now put that software on top. Which software? This one. How do you put it on top? You follow these steps. Quick start guide. You define a variable. Let's go put it side by side so it's faster that way. So I'm just putting it side by side. And I'll describe these things. The challenge I think I will have is most of you do not have an idea about what this Docker is and how do you run it. So it can be cryptic for now. So we'll do Docker, don't worry. But for right now, our focus is not Docker, but VPN. So bear with me. There are these steps that you may not easily understand because we haven't actually discussed what Docker thing is. It's a different type of product, like a virtual machine, but not really. It's a container for an application. That's what we are creating. And a new application fit in a container running on a machine, but it is not a VM. So we'll talk more about that. Right now, bear with me for these commands, which I have to execute for us to get a VPN server, and then we can connect to it and all that good stuff. So bear with me. We will discuss Docker pretty soon. Don't worry. Having said, side by side. So putting this on one half of the screen and getting the machine on the other half. 50% on this route, and we are now ready to run those commands, which is first thing, define a, let me finish this. You know, it's too much to describe. If I keep describing, I'll spend 3 more hours on just this description, which would be a bad idea. So defining this data example, what I'm doing is assigning a variable, by the way, and I'm creating a new volume by that name. A Docker volume got created. I'm going to run this configuration. And by the way, for user friendliness, you can assign a name to your machine like this, VPN server. So you can actually go to something like Sublime. You can probably make a record. So create an A record, something like vpn.domain, and then put the public IP like this. That makes it easy for your users to remember what was the IP address for the VPN server we got. This. That makes it easy for users. So it is easy and convenient. Otherwise, they have to remember this silly address, which is hard. right? So I recommend doing this. So I should actually do that right now. So I'll go to Cloudflare, my DNS provider, and create the new address record for this thing, which is login and login, and get a second factor from this machine, other machine. I have to get a second factor token. Okay, Cloudflare, please give me a token. And so it is generating a token right now. I will have to manually type 7828028. And now I'm going to create a new A record for the DNS name called VPN. And so here it is. Maybe I don't have any. So there is no record right now. So I'll create one by the name VPN. And in there, I will put in the IP address. Oh, not this, IP address, which is this. And by doing that, what I am doing is adding a new record so that the name vpn.cloudgenie.us actually points to this new box, this one. Now that name is in good shape, we should be able to go to the next step, which is here. What is that next step? It says modify this name to be your DNS name. So we will do that. Our name is vpn.cloudgenie.us. And that is, again, lots of Docker steps which are new to you, almost all of you. And bear with me, because my goal right now is to establish a VPN server ready. So we are doing these steps without understanding them for right now, but here we go. So it is now pulling down that image and running it. Next one is I want to initiate a certificate authority, which is what will generate certificates on that VPN server. So here we go. It initiates a VPN secure certificate authority, asking me for a passphrase. So I'm going to provide it a passphrase. It says verify the same one again. So I verify. It says, okay, what is the name of your server? I say vpn.cloudgenie.us. And then it is going to generate a long 2048-bit long prime number. Takes a few minutes, maybe a few seconds, depending on how quick the machine is. Now this will generate a certificate authority that will then be allowing me to generate individual certificates for employees in the company. And then I will hand off, hey, here is your certificate to connect to the VPN connection for the VPN server we just putting together. And that is what is now asking me to provide the passphrase again. So I provide that. I will enter the passphrase for the private key. And now it says a updated CRL file has been created for this location. So we'll discuss more about what a VPN is and what it does and how it operates. Right now, I'm more into getting it to ready and functional for us. We'll discuss all these things about what VPN is, how to get Docker, what Docker is, and all those things later on. Again, our focus right now is to get the VPN functional, so we can understand what the usage is and then get to details about what it actually does and how it builds and all that good stuff. But right now, we have to start an open VPN server process. So that is this step, which is what I'm running here, and it does. Next one is to generate a client certificate without a passphrase. So this certificate is I want to create for an employee. What is the certificate for my employee? That in my first employee in the company that I want to select, he or she gets a name. The name will be Nilesh. Or you can choose another name. Say, for example, Travis. Just picking a name, right? So choose that name right there. And this is going to be generating a certificate that Travis can use to connect to the VPN. And so I'm going to generate this for Travis. And I'm going to copy this right now and place it in here. So this generates a new certificate for Travis. And it says, give me a passphrase. Enter passphrase. So I'm going to enter the passphrase that I have. And it says, okay, I created a new entry for Travis. So new entity entry was created for Travis as an employee that can connect to the VPN server. Now that I have a client certificate ready for Travis to use, I should be able to retrieve that certificate and give it to Travis. How do I do that? This step. I need to go inside the Docker container and grab that certificate down. I need to modify this client name and make it Travis. Oops. Undo. And this client name that I have, I need to rename it to Travis. So now this is a file that will download from the Docker container to my local machine out there, like this. And now I have a file available called travis.openvpn. This file I need to give to Travis. How do I give it? I first of all copy it locally. How do I copy? I just say SCP, and then this location I want to go. So I'll say CP from Ubuntu location all the way to vpn.cloudgenie.us//ubuntu as the user, and the file name is travis.ovpn, and I'll bring it locally to my Cloud Genius workstation, and here it comes. So now, oh, okay, no such file. Okay, let's connect. Is there a file? Is the username correct? Yes, it is. So what is the location? PWD? It's home Ubuntu, not just Ubuntu, but home Ubuntu. Okay, so we'll go again, and it is home Ubuntu, and the file comes down. I have the file travis.ovpn locally available. Now this file is what I need to grab and give it to Travis. This is currently in my virtual machine, Cloud Genius workstation. So what I need to do is one step out and copy this file to my local network so I can give it to Travis in Slack chat or some other method, right? So I'll go to my local network, dump that file in there, and hand it off to Travis. So that Travis can then run OpenVPN client and connect to my virtual private cloud as the employee in the company. So I am going to browse my local network and go to my local NAS. Come on, go to the Flexbox location as a registered user. These are my internal credentials. And remember the password until I log out. So I am connected to my internal network where I need to drop that particular. This is kludgy in the way that I have to handle this file in multiple steps to get to it. Because we are first of all in the Docker container, then we came out to the Ubuntu machine, then I brought down to the local Ubuntu machine, and from the Ubuntu machine, I am copying it to my local, oh, where it is. Downloads folder. And there I need to go to the home folder where I have this Travis OpenVPN file sitting, which I need to move to the location here. Did it go there? I think it did. So now I have it on my local network. I can now put it in Slack chat. Slack chat and my local network, open up. And where are you? There is the machine, and this is the Flexbox, and there is Travis OpenVPN. And I need to take that to the Slack chat. So here is Travis, your file that is coming in group chat. And by the way, anybody can actually use it. I just dumped it in the group chat. And how do you use it now? So you have a plain text file called ovpn. Whatever that file name is. It's a large file with lots of things in there. Certificates included for Travis as an employee. And this is the configuration that we will use. Or anybody can, all of us can use to connect to the same OpenVPN server that is currently running. How do you connect to it? This is how you do it. I will demonstrate that. I will run a local client. So you need to run a local machine, needs to run a OpenVPN client software, and then pass the parameter as travis.ovpn file to it. And then it should connect. That's how it's supposed to work. So we have to have a client in your computer. I don't know if you have it, but if you do, you will run it like this. Let's see. If you have an Ubuntu machine, you will run it like OpenVPN client Ubuntu. If you have a Windows machine, Mac machine, all of them have a OpenVPN client. I'm just beginning to give you a OpenVPN client for Ubuntu to begin with. So this is how you do it. You have to run the OpenVPN install first, and then you connect like this. That's it. As simple as that. So let us do that. I will do it also. You can also do it simultaneously. No problems. I will now get to my Ubuntu box, which is here. And in that box, I will install OpenVPN local client software on the Ubuntu machine that I have running here, this machine. And how do you run it? Like this. You install OpenVPN software. The password is Cloud Genius. You go ahead and it installs OpenVPN client software. Once that is installed, you need to use it and connect to it. Connect to what? Connect OpenVPN client using the configuration to the path I provided, which is the travis.ovpn file. That's it. That's how you establish a connection to my VPC from your laptop, from your Ubuntu machine. If you're using Windows, there is a Windows client. If you're using Mac, there is a Mac client. If it is an iPhone, there is an iPhone client and Android client also. So you can just hook it up to any machine you like. Every operating system has a OpenVPN client. OpenVPN client, and you can find it on the internet. There are downloads available. There's a Windows download. There is a Mac download. I just showed you the Linux download, the Linux setup. So now that thing is installed, I need to run it. How do I run it? I have to pass this file to those guys. So I will have to run that particular step, which is this step, right? I have to modify it a little bit. How do I modify? Like this. So I have to pass the configuration, which is Travis. And that's the command. As simple as that. So in Slack chat, the command is coming down in your chat window. That's how you would do in a Linux box. And prior to this, you need to have OpenVPN installed locally. And so I'm going to run it right here. And I'm connecting to the VPC right now, and I am connected. How do I prove it to you? I can prove it by pinging a machine M1, just like that. I can ping machine M1 comfortably without having to do anything else. Let's go do that. I don't want to mess with this window right now. I will leave it running because it is active. So I will leave this window, which is my VPN connection established. I'll go to the other terminal. And in here, I'll just ping 10.0.1.92. And it is not pinging because I think we have to check the traffic rules. It is not pinging because my traffic from my VPN security group is restricted to the app security group. So it will not ping. I have to go and expand the route very, very clearly. And this is a good thing that we are running into, because go back here and in the security group section, you will understand why it is not pinging. It is not pinging because our application security group inbound rules are narrowly limited to just the NAT. But we have a separate item called VPN, and that is what is pinging, not the NAT. So we have to expand it and say allow all traffic, for example, as long as it is coming from the VPN, right? So this VPN security group I select, it allows every single traffic from the VPN box to anywhere inside in the application area, and I save. Once I have this enabled, it lets me ping, do whatever I like, just like that. So back here, ping, and it pings. You can do whatever you like now. You are in the cloud. My laptop is in the cloud. And if you, by chance, have installed a local OpenVPN client on your Linux, Mac, Ubuntu, iPhone, Android, whatever, and use the Travis OVPN file that I just pasted in Slack chat, you can also connect and mess up with my VPC, because I gave you credentials and an access to the VPN server that we have in place. Does that give you an idea about what we just did? I know there are lots of complexities here, and I understand, and I'll simplify it. The thing that I think you should skip for now is, how do you set up Docker? What is Docker? What is VPN? but more importantly, getting to understand what does VPN do for us. That is the goal of today's exercise. We'll get to the detail later on. Our goal today was to understand how do we provide our employees access to the VPC without having them to go through this burden of config file and jump boxes. And it's just complex, right? You just instant hand off this Travis Open VPN file to them. They will double click, boom. And that's how it should be. By the way, somebody just attempted. I can see it. Somebody just attempted. Who was that? Was it any of you that attempted to connect to the VPN server?
Wasn't I?
Okay. Looked like somebody did. Maybe I had to check logs and find out if somebody did.
Well, I think it was me, but I don't have the OVPN file.
It's in the Slack chat. It is in the Slack chat.
Yeah, right. I got it.
Okay. You can download from Slack and pass it as a parameter to the command like this, line number 19. Or if you're using a local client, like Windows, Mac, PC, or something like that, then you have to provide that configuration file to that software and use it like that. So another way, if you're using Macintosh, I can demonstrate that fairly easily, would be something like I installed the software called TunnelBlick. And then to that software here, I have to provide VPN details. And then in the VPN details, I'll add a configuration. And I'll say, I am going to just double click on the file. Will double click on the Travis file, should do it. So I'm just opening up Finder and looking up that file and going to that location where I have the file stored in this location where I find travis.openvpn, that file, and just double click on it. Should configure only me. And I provide my password. And there is a Travis entry now. I can just connect to the VPN server as Travis the employee. But I shouldn't be doing that. Because if I do that, I will logically place my machine, my Macintosh laptop inside the VPC, the virtual private cloud. And what does that do? It breaks my video conference, this conference right now. It'll break, it'll think that, oh, you thought you were in Sammamish, but now you're suddenly in where? East Coast, Virginia? The conference will break. If I connect like this, if I connect through the Ubuntu, it's no problem. If I connect through my Macintosh, the real machine, it will think that I moved suddenly. And that will break the conference. I don't want to do that. So I am not clicking on the connect button, but you can. Another way to see this implemented would be, let's say if I have another Macintosh, see if I can go there to the other Mac. What is the IP address there? Okay, what is the other Mac's IP address? 191.10.0.191. Okay. So I think this is not correct. I should connect to the VNC connection to the Macintosh 10.0.191. This should allow me to get to the other Mac and typing my password, connecting, and in the other Mac, I can go connect VPN, no problem. It will not break the conference. If I do it on this machine, it will break the video conference, which is not what I want. So here's the other Mac. And in that Mac, I have the same file, Travis file somewhere sitting. So I have to go there and I'll open a Finder window. And in the Finder window, I have to also run this way to connect to the mount the remote network, which is my network attached storage. And then in that location, I have to go to, where is that mounted? Where is Travis? That's what I'm looking to find. But Travis is probably here. Travis is in Slack chat. Siri is kicking in. No.
He said he had to reboot. He said
Me?
Travis did.
Travis did not reboot.
Yeah, I rebooted. I joined up, and then just like you were saying, I had all sorts of video conference problems, so I
Yes.
quickly
Yes,
quit
yes,
that
yes,
process.
yes, yes, yes. Totally expected, totally expected. And I that's why I did not attempt to connect, but maybe another device. You can connect through through Ubuntu, no problem. It's a different machine, right? So it doesn't matter from that perspective. So that's why I am connected to a different Macintosh right now to illustrate the point, which is what I have. I'll go to the machine where I have the Travis file sitting. And so that was you indeed that got attempted to connect to that, which is nice. So I am looking up your Travis file. It sits there. I am going to import that file into my software locally for me, and then say connect. And this should establish a VPN connection like that. I can connect to Nilesh, which is the other VPC I have. I can connect to Travis. And it is now connecting to Travis right now, authorizing, and it is getting configuration. And you can see this in this window. And it is connected to Travis, not connected to Nilesh. There are two VPNs I have to two different VPCs. One is the Cloud Genius production VPC, and the other one I just established for you for demonstration. So now in this computer, I can go to the terminal here and make it big so you can see it a little bit, but I should be able to ping 10.0.1, and we have an address conflict. My internal network is also the same IP address as that of the Macintosh, which is crazy, but you can see it is pinging. And maybe it is not the address conflict. Let me check the address here. Maybe it is not a conflict. Yeah, not a conflict. So it is actually pinging the box M1 from my iMac. I'm breaking it. And I broke. But that routing is comfortably possible because I have a virtual private network connection with the virtual private cloud that we built from scratch. And we were able to experiment with all these examples, right? Let's go see. So Travis says doing a quick reboot, which is forced on you because you just set up which was the OS underneath?
Yeah, Arch Linux, and I did OpenVPN and was getting this device not found. Did a quick Google search and it said reboot, so I did. And it worked.
It creates a tunnel device, a tunnel network adapter device, and that's what forces a reboot on some distributions. In Ubuntu, it doesn't. So that way you did not see me reboot on the virtual machine. But reboot is okay. I mean, yeah, sometimes it is needed.
At least my Python magic works.
Yes. Yes. So let's quickly summarize what we discussed. And with pictures. So I'll draw by hand. Let me get rid of some of these windows. There are too many windows open right now. So screen sharing should be disabled between the iMac. So I'm quitting the iMac screen. What else I have open? Yeah, this should also be, I'm breaking the VPN connection also, by the way. This VPN connection I have in the command line, I'm breaking that. So I break that. And now I cannot ping. I still ping. Crazy. Who are you pinging? Yeah, you see, I have to understand what is being pinged. But let's first conclude what we discussed before we go into diagnosis. So this aside, and staying focused on what we created today and what we did. So back in the VPC section, that's what we focus most of the time on, VPCs, right? So in the VPC section, there are these four different wizard choices. We did almost 3 of them today, but we did by hand, by scratch, beginning from scratch. We did this one just to begin with, establish a NAT machine, connected to the private, connected to the public network. That's what we began doing. We expanded it to create another subnet, like a private area, in which we have M1 running. And in the public subnet, we had a NAT running. We tried to make use of that NAT as a jump box, which is in principle a bad idea, but we did that either way. Then we said, you know what? I want to understand this NAT business. So we get to the third way of doing things. And we injected a VPN connection. To inject a VPN connection, we need to have a VPN server running in the VPC, for which you could cheat and use the NAT device as a host for your VPN. And you can cheat and save and all that. And it's all a bad idea. Don't do that. But you could, technically possible. It is a good idea to keep the VPN server separate, not mix it up with a NAT. Just one purpose in life, one box, one segment, one something. Keep things simple is a good principle to have in a large scale enterprise scenario. So one thing, one purpose, you get good results. Try to mix things up, you have a disaster. Eventually it will happen, if not right away. That's the reason why when you want a VPN server, you should create a separate box. And that's what I actually did. Separate box, converted that box into a Docker host, and then running a VPN solution was easy. I mean, a few commands and then we have it ready. That is what is possible once you have Docker going. Now, Docker we did not understand. We did not even discuss. We did not discuss how a VPN actually functions. We just used it blindly. I just gave you a file and you and I were able to practice with it. Because our goal today was to understand how routing works, how people in the company can route traffic from their laptops, desktops, their machines out to a private cloud. This example was the third scenario here, the third scenario in the wizard, which is you have a public subnet, a private subnet, and a VPN connection. The fourth one is actually trivially simple. All you need to do is break your NAT and throw away your public subnet. That is this. And you need to run your VPN connection, which is a dedicated VPN provided by Amazon. So Amazon also provides VPN. Amazon also provides a NAT solution. The examples I chose today, by the way, are handcrafted, meaning, let me describe what I mean by that. If you go back to the VPC section, Amazon would, if you ask Amazon, hey, how do I get a NAT device? They'll say, what? Don't get a NAT device. Use a gateway. We have a NAT gateway. Use that. That's what they will recommend because that's what they have. But if you want to, do something that is portable across a variety of clouds, you should create your own NAT. That's what I did. This NAT gateway is not available across other clouds. So if you want to understand how other clouds will do such a thing, other clouds may not have the solution. So you need to know how to build it from scratch. We used a ready-made machine that we used as a NAT device. Amazon gives you this choice called a NAT gateway. So if you configure this NAT gateway, they will create it for you, create a new machine, put it for you, do the whole thing, and give you a gateway for you to be able to route traffic just like you would do with a regular gateway, IGW. They call it Internet Gateway. This is a different gateway, NAT gateway. It is protected via a network address translation machine, basically a router. That's a solution that Amazon provides, not other clouds, just Amazon. So that's a difference. Amazon also provides an egress-only internet gateway. Egress only, meaning it can only go out. There is nothing that can come in. It's a one-way traffic gateway. That's another choice that they have. You can use it if you like. Nothing wrong with it. But just understand that other clouds may not have it. So I tend to use structures and examples, handcrafted, that are portable across multiple clouds. You can do the exact same thing in any cloud you like. And totally, you can do it in even Vultr Cloud and DigitalOcean, smaller, simpler clouds, because I don't actually use the ready-made solutions that these companies tend to provide, like NAT Gateway, for example. So I go basic principles, first principles, begin from a bare bones machine and add components as you need. That is my style of working. It may not suit some people, but that's what it is. I just want you to know that there are other choices available. My way is not the only way. but it's just my way. It is not, not my way or the highway. You have your own way also. So you can choose your ways. Back to our VPC discussion, we have created this VPC, and in here, you will find that I chose by design, did not choose whatever they give me by default, because I want us to understand how do you build things from scratch. That's how I tend to do most of the things, is all from scratch. And with this, let me see if I'm missing any point to discuss for VPC discussion. The thing behind VPC is we did not do today. I think that is something that I want to briefly discuss and mention, is you can extend this VPC idea even further. Like, I discussed this idea of a subnet 1 and a subnet 2 and subnet 3, and I called it public subnet, for example. We call it private subnet, for example. But they are these were just two examples. You can have any number of such subnets like that. And so any number of subnets, depending on how many layers and layers of applications or multi-tier application that you want to run in a given situation. All of these different subnets will typically belong in a availability zone. Let's go check that out. And that basically translates to this idea here. So if you go look at any of these subnets and carefully look at the public subnet, the availability zone here is US East 1E, as in echo. Let's look at the private subnet also. Click. It is also US East 1E, as in echo. In case of creating a new subnet, you have the choice of creating a subnet called S2, for example, in the CloudGenius VPC. And here, you can choose a CIDR block of 10.0.20/24, for example. But before you click create, you also have this choice that I did not discuss. And this A, B, C, D, E, F, 6 different availability zones. What do they mean? Let's go figure that out. So this was availability zone US East 1. This stands for Virginia. And then we had a E at the end. In Virginia location, there are A, B, C, D, E, and F, 6 visible to me, availability zones. There are probably more than 6, but I get to see only 6 of them at this moment. Just 2 months ago, I was able to see only 5. I think most of you also see 6. They probably have more than 6 availability zones in the Virginia area. And they choose 6 of them to show you and 6 of them to show some other people, and like that. They distribute workload. Now these 6 regions or these 6 availability zones are independent fault tolerant buildings. Something like, you have a building in one side of the river and the other building on the other side of the river. Or maybe one building on one side of the fault zone from an earthquake perspective and the other side of the fault zone from the earthquake perspective. So you basically divide your building structures in a fashion that are independent from each other. So if there is a light outage or any power outage or any kind of disaster happens, it is less likely to happen in another availability zone. That's the idea I think you should remember. And all of these things that we just did, S1, S2, we did today only 2 subnets today. We did only in one availability zone, which is primitive, to say the least. It is a primitive way of designing, which means we should design better. How should we design better? We should do something like this. S1, S2, S3, like that, Sn. All subnets that we need, as many as we need, right? These guys will belong in availability zone. Let's call it the E availability zone. Just for this example, we'll create an exact replica of the same thing, S1, S2, S3, ... Sn in another availability zone. Let's call it the F availability zone. And by doing that, we are able to reduce the level of trouble that we might run into, because we are doing our deployments of our subnets and our applications and our NAT devices. There is a NAT here and a NAT there. There is a jump box here and a jump box there. There is a VPN here and a VPN there. You can basically go like that. And there are machine M1 here and M2 here, and M3 here and M4 here, like that. There is a database number 1 here and database number 2 replicated here, if you like, or you can use a database service if you like, multi-AZ availability, multi-availability zone database service. And by doing all these things, what you're really doing is improving the availability of your application that runs here, wherever it does. That's the kind of design that we should create in multi-availability zone setup, which is not how I wanted to begin the discussion, because if I began with this idea in mind, it would have it would be hard to digest. And that is why I did not even bring up the idea of availability zone to begin with as we started to build our VPC step by step. I did not even mention anything whatsoever about availability zone at all, because it would have confused all of you for no reason. And therefore, I held off to that idea until now, when I'm now describing to you that it is even better to have your applications split in 2 different availability zones, sometimes even more, depending on how much reliability, availability, and serviceability, and all these utilities that you have in mind, you want to improve them, you can, provided you split your work in at least 2 different availability zones, like E and F, as you begin designing, as you begin implementing. So here for S2 that I have in mind, maybe I can select availability zone US East 1F and then create a subnet. So it will be a different availability zone. Basically think of it as a different building. Now you have to plan for it and think through the whole thing, put together a design that is suited for your application, and then implement the VPC layout as you need to for your given application. And that is one of the reasons why these trivial wizard-based solutions do not actually work. You have to understand what you need and make your applications highly available across multiple availability zones as you build out a solution for real. You know, clicking wizards and yeah, make a VPC, click, that doesn't help anybody. You know, it is for children, literally, to click this button and play with the VPC. That's what this is basically. I don't like this wizard, so I don't use it. And I don't want you to use it either. I would like you to rather have the understanding of building what you need from a design perspective. And there is a question from Travis. I noticed EC2 is all segmented into zones, whereas S3 is global. Scratch that. No, it is not. S3 is also limited to a region. And in Google storage, you will find it is a multi-region storage. So they have a slightly edge over the ability that Amazon has. So slight differences among various services, you will see that. But S3, you have to choose a region. By default, they just go to Virginia. But you can choose a different one. So like I think Tammy and Mark, both of you selected Oregon as your bucket holder, which is fine. You can use whatever you like. More importantly, you put a wrapper around it by putting a content delivery network on top of your bucket. That makes it globally available from a usage perspective. So with this discussion, I was pause recording and wait for questions. So I want to make sure that you understand this idea that I just described to you. And we'll do examples like this. This is really daunting to build by hand. So I would suggest that you play with this idea of building out your own VPC, understand flow of traffic, understand how you create machines, NAT, jump boxes, VPN servers. Maybe hold on to the VPN part because it can be a little bit difficult. You have to understand Docker and then a container technology and then get to VPN and then get to use VPN, which we did today, but without understanding it, which is not what I like. But I had to do this to show you because there was a question. So we showed you the answer. And now, the thing I would like you to do is make sure that you completely and fully understand flow of traffic and the concept of security group. That will help you in a big way. And these concepts apply to everything. It can apply to your local networks in your company or in your home. You can solve your routing problems your own, which you already do, but in a large scale, you can actually apply the same concepts to a real physical cloud or physical setup in your company and apply the same concepts to the same things that apply: routing tables, firewall rules. It's the same concept applied to a software-defined network like you saw today in the case of Amazon example. So with that, I'm pausing the recording right now.